forgot my little webcam cover. Get me in frame. Good morning, everybody. I'm just going to wait for a second while the live stream catches up with me and tweet about this. Comparing unsupervised text classification methods. Come join, smiley face. Okay, excellent. Oh, there we go. And it started. Good morning, everybody. Today is part 2 of the project that we started last week. And last week we did a little bit of scoping, a little bit of discussion of things that we are interested in doing. Good morning. No, it's so big. Sorry, I'm having some trouble with Windows management. I'm so tired, you guys. For some reason in my mind, I was like, oh, this will be an easy week. I'm not doing a lot. I'm at a conference. I mean, not physically right now. It's in Seattle. But like, I'm giving 3 talks this week. I'm doing my usual live coding. I filmed the next coffee chat with Amanda Kasari, who is a DPE manager, like in developer relations at Google. And we talked a lot about data science workflows. And just catching up on a bunch of stuff because I had a bunch of travel. I'm really tired. I've done a lot, and I have a full day today, and then I have a meetup tonight, and then I'm just gonna like lie on the ground like this, just like moaning softly. Good morning, everybody. Mobasir says, when will you teach us deep learning like this? That's a good question. I don't have a super solid plan. I just want to keep working on this project for a while. In general, I think for the majority of projects, deep learning is not actually the right choice for data science work. And I actually did a talk about that at PyCon. And he says, it's an appropriate time of the year for summarization. Did I misspell summarization? I often misspell summarization, so if I misspelled it, my apologies. Anyway, oh, I see. There's no spell checker in kernels, which is a constant trial for me. So, what are we working on? So I read the Kaggle forums pretty much every day. I read all of the forums that aren't associated with a specific competition, and I read pretty much all the forum posts, and I don't always have time to respond to everybody, but as you can see, there's a lot. The number of Kaggle users and number of Kaggle posts on the forums have been growing pretty much exponentially since I started, and when it used to be super... I would get the meta Kaggle data set. There we go. When it used to be super doable for me to spend like 4 minutes in the morning just reading through the forums, now it's taking closer to, half an hour, 45 minutes. And so I want to build myself a little program that can help me speed up this process and make it easier for other people to understand what's going on in the forums by using the information on the forums and some NLP to summarize topics, to highlight things that might be problems. So if like a lot of people are reporting a bug that maybe our alerting system didn't catch, sending people information on that. And then lots of discussion about resources for deep learning. So last week, we did a lot of talking through the problem, specifically what I want, specifically what I'm looking for. And I think the first thing that is going to be, let me start editing this kernel. The first thing that is going to be relevant to us is summarization, but also, why are you not editing? Edit. There we go. I didn't actually click. I just sort of like hovered with my mouse. Figuring out a way to do clustering, to do classification in an unsupervised way. So questions about getting started on Kaggle, we actually have a series of videos that I need to update with the new editor, and we're working on that, sort of like how to get started on the site, like what all the different parts are. So I check those out. I think it's Getting Started on Kaggle is the name of the playlist, and it's on our YouTube channel. So I'm actually going to start a new section. Let's call it week 2. If I were working on this full time, I would obviously have done more than what we did last week in a week. And week 2, comparing unsupervised text clustering / classification methods. So last week we decided that the sort of things that we were interested in were summarization, so some way to take all of the forum posts and condense them into a more readable, easier to digest format, maybe with some sort of idea of the trends that are going on. Flagging questions, so these are questions that I would like to answer based on questions I've answered previously. And this won't be in the MVP, this is just something I'd like to do later on that I don't think should be part of the first stage of this project. And then also alerts. So if something is happening, a lot of people are reporting the same bug, a way to sort of like, hey, all these forum posts are on this bug, this is probably something that's a problem. So we had a bug earlier this week that was fixed within the day, where the cells were a fixed width for maybe a couple hours. And we knew about it because we have, we knew about it because people looked at the problems with their eyes and were like, yep, that's a problem. But it'd be nice if whenever people start to report bugs, we could get an automatic ping like, hey, something's up on the forums, check it out. And that's also not going to be in the MVP. So the first thing that I'm interested in is summarization, this way of taking this text, which is a little bit structured in that it's in different forum topics, although those tend not to be. So let me open the tab so you can see what the forum topics are. So here are the general buckets for the topics. These tend to be very loose, so a lot of things get answered or asked in Getting Started and questions and answers that could very easily be asked in the other one. That's part of the structure that we have. We don't have tags for forum posts, so you can see that there's no informational tags here that people can add. So getting from text to so we don't just want to get from text, we want to find and group forum posts on similar topics. There we go. Christopher says, will you also create the data set you'll use? So I'm not going to in this case because Kaggle actually makes all of their forum posts public. So the meta Kaggle data set is one that we share with you guys. Anybody can look at this. And in this data set, we have the table forum messages. And this is just the text of all the forum posts that haven't been deleted. And here you can see when I was talking about the sort of exponential growth and how I cannot read all the forum posts with my own eyes into the future. This is the thing I was talking about. And I will have to, if I want this to be a little bit more real time, because I believe this is updated daily, if I want something more streaming, I'm going to have to build an interface to our database. And that I would do off stream for security reasons. So I might, but you guys won't see it. Sorry. And Kamal says, can't the alert system be done by a simple formula? So I think we could do alerts like, hey, there's more forum posts now than there were previously. Like we're seeing a spike in the number of posts. And I think that could be pretty simple. But to actually be like, hey, there's more forum posts and they're around a specific topic, we need a way to determine which posts belong to which topic specifically. So this is really, I would actually call this part of feature engineering. We're trying to find a way to develop features that will tell us information about how to group forum posts. All right, so there's, my advisor loved this this thing, the map of Peru, where the best possible map of Peru is the country of Peru, but you don't, if you have like the most detailed possible map, then you don't have like the ability to look at it quickly and understand broader patterns. I feel like that's a magical realism short story about someone who's just trying to do a really good map of Peru. If you guys have read the story, feel free to put the a link in the comments for more information. And let's talk quickly about some of our challenges. So I alluded to one of them. We don't have labels or tags. So there's no way for people to tag their forum posts. If you use Stack Overflow, they have a really rich tagging system. We don't have that on Kaggle. And it hasn't, I don't think it's especially a big problem. It's just a type of metadata we don't have access to. So that's one challenge. So another challenge is that topics slash custers will change over time. So for example, if people start talking about like a new NLP paper, so a lot of people are talking about BERT and possible applications of BERT, which there have been a lot of discussion, mostly on the competition forums, and we don't have a cluster for BERT and we don't know about BERT as a topic, and then when we try to use our existing model to classify new forum posts, we will fail to observe that that's a trend. Christopher says, Mad Peru. That sounds right. I don't think I've ever read the story. I just heard the anecdote from my advisor. We don't know how many clusters slash topics we have. So another challenge is for something like k-means, you have to pick a k. And there are some heuristics for picking k, but they tend to be a little bit computationally intensive. And we expect that to change over time. Other challenges, if we try to, so let's see really quick, is this by date? This is not by date, but we can do a little quick maths. So in, actually, can I get, here we go. So if we had between, there we go. If we had between January 18th and March 26th, 35,000 topics, then that's, what would that be, like 30 days-ish? No, like 60 days, so 35,000 divided by 60. I'm doing it back at the envelope. I just sort of want to get a general idea. So we only have about 500 forum posts per day. We don't have a lot of forum posts per day, less than, well, I'm going to use that for approximation. So let's say roughly 500. I think that seems reasonable. And it's obviously going to have like some seasonality there. And the reason that's a problem is if we want to have sort of a sliding clustering. So I've been thinking about this a lot. And my first instinct was like, oh, we'll build a model and then we'll just apply it to new things, right? Like we'll build a classifier and then we'll classify, once per day and then just send us the results of the classification. But the problem with that is that a lot of methods will have a stable number of classes, and we expect that the classes will change. Necroduke says, if a forum post title would be, what's your favorite animal, what would you post there? Me personally, I have a pet hedgehog, so I really like hedgehogs. If you're asking which forum it would go in, we don't really have a random one. Maybe questions and answers. Also, fun fact, hedgehogs are not an ImageNet. So a lot of the animal recognition stuff don't know about hedgehogs. So TensorFlow Lite, the embedded ImageNet image recognition library, it does not know about hedgehogs, which is sad to me personally because it means I can't do cool Raspberry Pi projects for him. I could build it, I'm just not going to. Okay, so 500 examples, especially because that's 500 examples from all over the site. So that includes competition posts, that includes I don't actually know off the top of my head if this includes comments on data sets or comments on kernels. I'll do a quick scan to see if it might be somewhere else. But I think it also includes comments on kernels. So we just have sort of, I don't think it would be in any of these other tables, which has bitten me before. It might very well be in some of these other tables, and I've just not caught it on this scan. Necrotic says, what about CFAR 10? I don't know off the top of my head. Also, that's not how you spell form. So that's not a lot of data, especially for an unsupervised method. So I guess what we could do, okay, so, and I do have, I had a tweet that I did 2 days ago, and I got a lot of really good suggestions for different unsupervised methods to use. Oh, hey, and there have been some since the last time I checked them. So there's a lot of potential algorithms or applications that I'm gonna look into. But just in terms of like what the pipeline is going to look like, we could run model weekly and apply daily. So we could do like sort of like a sliding scale where I do all my topic modeling for the previous week, and then I say, hey, here's the ones that are interesting today. So this is something that I want for myself daily. For the rest of the team, maybe weekly might be a little bit more manageable, because I don't want our engineering team to be like constantly checking the forums and refreshing when they've got other stuff to work on. Division of labor. Jared says, damn, I forgot to post my suggestion in that tweet. You can do it now. There's nothing stopping you. And I'm going to keep looking at it. So one thing that I know that I want is use unsupervised methods. And the reason is that like I said, the number of topics is changing. I don't necessarily know that we're going to have examples of a current topic in our previous data. So if I spend a lot of time sitting down and tagging posts, unless they're very broad tags like bug report, feature request, help request, spam, I guess, unless I'm using extremely broad tags, they're not going to be super useful going forward. So I really want to use unsupervised methods, and run to address sparsity of data. And I also want to run model continuously, or batch run. And that means that because we do want to run it a lot, inference time is suddenly much more important. No, not inference time. Training time is much more important. Important to consider. Because if I'm running one model that I'm training one time and it takes 3 hours to run, that's fine. That's fine. That's not even that long. But if I'm running this once a day and I need like 3 hours of GPU time every day, and it's running automatically, that can kind of add up. So I want something that's a little bit lighter weight, and even something maybe I can do as a kernel might work for me. We'll see. I don't know for sure if I'm going to do this in kernels, because I don't think I can send myself. I don't think Slack will. Where's my bag? I don't think they're in here. Anyway, I have some little booklets from Slack about the Slackbot API, and I'm pretty sure I can't. Maybe I can push to the API from kernels. I don't know if I want to. Anyway, I might do some of this on GCP instead. So training time is important, and I'm also going to put cost in there as well. Yeah, especially since if I do need GPU time, I'm probably going to have to take it from the same pool as all users of Kaggle, and that seems like a little bit unfair. Yeah, and this is part of the reason why I want to stay away from neural networks, because those are going to take a long time to train, and we definitely don't have enough samples. Like 500 samples assuming we're running this daily, is not enough to train pretty much any neural network. And Carmen says, you probably wouldn't want a GPU, right? A CPU should be fine. Yeah, no, absolutely. I agree. And that is part of my goal. If I wanted to do something like I have like a sliding monthly window, and I have, 35,000 or whatever, or probably more like 15,000 posts per month, and then I sort of retrain daily, then we might get into needing to do some parallelization. But okay. Now we can actually get to unsupervised. Yeah, so sorry. What I'm thinking of is clustering versus classification. So if we want to do something where we're like, hey, we train the model on the previous month's data and then classify today's data, then if there's a new emergent topic, we're not necessarily going to see it. So I think actually clustering is going to be a better approach for this particular topic than classification. Ryan says, rather than spending a month figuring out an unsupervised machine learning problem, just label some data for a week and train a classifier. I would definitely do that. I tend to prefer supervised methods, but because this is something where I think the underlying data that we're trying to model is going to change pretty significantly pretty quickly, I don't want to label 15,000 posts, every 3 months to make sure that my classifier is staying on new topics, because I expect that new topics will emerge. But yes, that is good advice in general. In this particular instance, because we have the challenges that we do, I think unsupervised is the way to go. And I could be wrong. I may have to eat some crow later on. Okay, so some approaches to unsupervised text clustering. So my plan is to, and actually I'm going to pop this out into another, I'm going to pop this out into another tab. Oh, I guess I can copy back and forth if you guys don't mind that much. Oh, and I use this emoji to mean NLP because it looks like text in a matrix, kind of. I know it's supposed to be like a telephone keypad. So here are the ones that we talked about last week. LDA. I'm just going to actually say too slow, not great for us. And also can be a little bit hard to interpret. And Carmane says, extract keywords and build up a taxonomy over time. Yeah, that could definitely work. So we talked about, or someone brought up, and I don't remember who it was, sorry, it's definitely in the last video, unsupervised keyword extraction, YAKE, which I was not previously familiar with, but I think it could work pretty well. I think keywords have the benefit of, actually, let's make keyword extraction its own thing. And so this is clustering. And then this is topic modeling. Sorry, I'm just, I'm breaking these down so it's a little bit easier for me to keep track of, ooh, ow, everything. I bang my elbow. Nicolesh says, interpret is spelled wrong. Was that right? I don't know if I've mentioned it on the channel. I think I have a couple times. I'm actually dyslexic, so spelling in particular is very difficult for me. I almost failed 3rd grade on account of being really bad at spelling tests. Mobus here says, Toby Segarin said in his book, Programming Collective Intelligence, that hierarchical clustering works really well for small data sets, and has also applied hierarchical clustering for blog posts. Oh, interesting. Hierarchical clustering. I think that k-means is actually not a good choice here because we need to pick K. And there are some ways to sort of like validate your choice of K, but having to do that every single day is going to be a little bit of a pain. So I think embedding and K-means in particular is a poor choice. And we could do clustering with embeddings is probably going to be the easiest way to do that. All right, so other things that people told us about brown clusters, which I did look into. Let's see, brown clusters, NLP, and I found some really great slides. Maybe it was this one. Yeah, I think this was this one. All of these slides made with what's it called? Blazor? Blinder? This the LaTeX slide package is hard. They all look the same to me. That's the end of that sentence. Nakaduk says, speaking of dyslexia, how would you treat misspelled words? Really good question. We could apply some sort of spelling correction. My worry there is that if something like a new model name is treated as if it were misspelled, we're going to lose valuable information that way. So I'm probably just not going to... Beamer! Thank you, that's the one. Sorry for clapping in the mic. Beamer for the slides. So I'm probably just going to ignore misspelled words. I'm not going to do a lot of pre-processing. That's my idea so far. Okay, so these are clusters of words. It looks like they're not of documents as much as documents. Okay, distributional hypothesis. This is sort of the and these are sorted by. I don't know how these are sorted by. It's not number of upvotes. It looks like whether or not I've hearted it is part of the sorting mechanism, but not the whole thing. Li Ling is one of the developers of NLTK, and I really trust his opinion. So that's why we're starting with this. Okay. Similar words have similar distributions of words to their left and right. So this looks like it's more of a... so this is more of a bag of words. So vocabulary, you're partitioning the classes. Okay, and then we measure the quality. I'm not going to read through that. Assume that I did. We got the number of times class C occurs in the corpus, the number of times C prime is seen following C under the function C. Okay. And then let's see, number of times class C. I don't know what C prime is. I don't want to go too deep into the math. I just sort of want a general overview. Each word gets its own cluster. Our game is to get K clusters. Do we have to specify K? Is my question. So it's clusters to the 5th training time is naive. Yeah, I would say that is too slow. I would definitely agree. Yeah. Duke says, little c, C prime, big C. Yeah. Second algorithm, take the top M most frequent words. Each one gets its own cluster. Okay. Running time, and this is the number of clusters, M squared plus N, where N is the corpus length. So our corpus isn't that long, so this could be a really, really useful thing. And this is, I should say, it's a little bit vintage. This has been around the block a couple times. But that doesn't mean it's bad. N-grams and a lot of older NLP methods that were designed to work with really, really limited compute compared to what we have now are often super good for this type of, application where I want to do this relatively quickly and I want to do it every day. So I don't want to spend a lot of time and money running parallelized code. Ryan says, in one of my first projects, I did topic modeling on tweets in Vegas using TF-IDF, term frequency, inverse document frequency, and LDA, and came up with a topic about a guy who lost a bet and was wearing a diaper. Carmine says, if it says HMM, you know it's a blast for the past. People still use HMM. For real, though. It's in a lot of ASR methods in particular, still HMM based. I mean, like, neural methods work pretty well, but if you have, 4 total hours of speech in your given language, you do not have enough data to train neural methods. Okay. Yeah. Okay, this sounds like me. I've got a really dynamic problem. I don't want to spend a lot of time annotating. Okay. Discriminative plus clusters plus actives. They're updating over time. Improved part of speech tagging for online conversational text with word clusters. Okay, 2013. And it looks like Percy Leong has some code on GitHub. And Joshua Goodman has a dead link? No, here we go. Gotcha. We'll dynamically change the complete page's context to that language. All right. It's a clustering program that produces hierarchical binary branching tree structured clusters. It only runs on Windows. I stream from Windows because that's my home computer, but my work computer is Linux, so that's not going to work for me because I don't want to deal with wine. That's just a pain in the butt. Okay, implementation of the hierarchical clustering algorithm, a sequence of words separated by white space. So this is clustering based on words, and then we could model each forum post as maybe a GMM of each of these, a GMM composed of the topics, the clusters for each of the words that are in it. We could maybe project it into some sort of vector space and do clustering based there using some sort of distance-based method. So this is definitely a potential. Is this in Java? That is my main question here. H. I don't even know what the H file extension is. Cluster viewer? HTML viewer. Okay, so we may need to do a little bit, let's see, round clusters, hierarchical, work on the word level can be updated actively. Carmen says, without looking at the math too closely, this looks like an oh my gosh, sorry. Agglomerative clustering of word vectors. Agglomerative. There we go. I found it. I had to dig around in the oatmeal for a little bit. Since they're saying words that appear close to each other are semantically similar. Oh no, it's C and C++. Would need to find Python code. Yes. Hierarchical clustering, think dendrograms. Yeah. Like for evolution. I'm sure that's not how you spell hierarchical. So that's one option. It looks like it would be pretty fast to run. Presumably they got it to better than, what was it? Ternary time? Hopefully. Something else to look into. So definitely an option there. And Brendan Chambers, who is another linguist that, again, I respect a lot, speaking of hierarchical clustering, uses dbScan for clustering. So let's look into that. dbScan. Not something I'm familiar with. So dbScan is density-based spatial clustering of applications with noise. Data clustering algorithm, been around since 1996. Non-parametric, excellence. We're not making strong assumptions about the underlying distribution, which I don't think we have good reason to in this particular application. Groups together points that are closely packed together, blah, 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 distance-based. Marking as outliers points that lie alone in low-density regions. That seems like extremely reasonable clustering. In 2014, the algorithm was awarded the Test of Time Award, and at the leading data mining conference, KDD. I've never been. Prometheus says GitHub lists the languages in the repo at the top. Oh, it also says C++, literally right there. So that's how my day's going. Thank you. I don't see... Maybe it's because I'm... Whoop. Yeah, maybe because it's not I don't see it, but I do believe you. The pink bar. Oh, I see. And you have to click for language details. That's super helpful. There's a teeny bit of Python in here, but not a lot. Okay, so it's mostly C++ and C. So presumably it's very fast. But also, I don't especially want to mess with it. Also, I think a lot of our internal C stuff in Kaggle is actually C#. Like a lot of our metrics are written in C#. So it might not work super well with our existing pipeline. And that's just a consideration for me. Thank you. Good tip. I learned something about GitHub today. Oh no, because I clicked on it, I lost my thing. What were we looking for? dbScan. dbScan for clustering. And somebody mentioned, Carmenia says you don't need to know the number of clusters, and it's in scikit-learn, which is fantastic. Why should we use it? I would like to see like a quick discussion of some of the potential drawbacks about this. Well-known data clustering algorithm. Is it? It must be. I'm just not super familiar with it. I should say, I don't do a lot of clustering. So potentially a problem. Hard to find manually. Yes, excellent. Practical applications. How can we implement it? It's pretty much in everything. So we've got a couple of options in Python. We've got a couple of options in R, which is nice. And there's a nice little Portuguese example to walk you through in C++, if that seems like something you are interested in. So I think for clustering, dbScan looks like a good choice for us. So we would need to do, the benefit of brown clusters is that they are designed to work with text input. dbScan looks like it needs embedding input, I believe. Yeah. Needs embeddings for input. Should reduce dimensionality, which makes sense, especially if I'm training my own embeddings. Jer says, dbScan assumes same dispersion between clusters, doesn't it? That's a good question. I don't know. dbScan dispersion between clusters. Assumptions. There we go. That's a better question. When to use it, how to use it. Is this the Netflix blog? Okay. It's just about Netflix. I gotcha. For each point, forms an n-dimensional shape. Iteratively expands the cluster. Graph. Yeah, these do look relatively... Sorry, I'm reading. Starting at random points. Minimum number of data points we need to determine a single cluster. How far away can one point be from the next point within the same cluster? The minimum number, points they're setting in order to be considered. dbScan does not necessarily categorize every data point and is therefore terrific with handling outliers in the data set. Okay, that's interesting. That's a good visualization. For those of you who aren't necessarily great at colors, here everything is one color. Here the sort of chunks are one color, and then the sort of spattered dots around are the same base color. So they haven't been clustered. Carmenia says, Whoop, 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 whoop. The only problem is if your clusters have different densities, it doesn't react well. Yeah, that makes sense, because it would say that the really sparse cluster would be actually outliers instead of treating it like a cluster. So note, clusters should be of similar densities. So one benefit of dimensionality reduction is that we can help ensure that. So we can go from a very sparse space to a less sparse space, and we can check the density after reduction. Okay, and then HDB scan is hierarchical. Thank you, hierarchical. There we go. And that was Carmen. Yeah, I mentioned that. So helpful. All right. Ted says, LDA, in my experience, k-means is unreliable in high dimensional space, and I'd go with dbscan instead. Yeah, and I just decided, based on a lot of feedback here, and also just like thinking about it for 10 minutes, that k-means was a bad idea. So we got there. So TF-IDF plus PCA plus clustering. So TF-IDF instead of embedding, to sort of take your words and convert them into words to inputs. So we could do embedding, which is probably what I'm going to do, because I can use pre-trained embeddings. We could do TF-IDF. We could do LDA, which I'm probably not going to do again because it's a little bit slow. TF-IDF, I guess we could use, it's not generally that slow. My big problem is that the clusters that come out of this tend to be a little bit more difficult to interpret. I have a slight preference for keyword extraction, I think, because then you get a single word out. Yeah. So that is one option. What else did folks bring? Leland McInnes, who is a researcher that I'm not super familiar with and also doesn't follow me, but it seems like a good suggestion. So you take the term frequency matrix, remove the expected frequency by subtracting or using the column marginal as a noise model. So if we have sort of a language model trained on Kaggle as a whole, then we can use that to determine when specific terms are used more than they have been historically. UMAP for dimensionality reduction, and HDB scan for clustering. So this is sort of so the thing that is different here from what we've talked about previously is taking this stage for actually doing the movement from words to input. And this is by Leland McInnes. I just want to give him some credit. No. Leland McInnes. Lelandmins. Is that close? ES, and the I should be capitalized. All right, so that's another approach that we could use that it sounds like has some road testing that works well. Medmule says you could do word embeddings weighted using TF-IDF. Yeah, we could. Embeddings weighted with TF-IDF. And what I'm probably going to do is I'm probably going to compare a couple of these. So I'll probably put my my preprocessing in a couple different utility scripts, so just script kernels, and then do a little bit of experimentation where I try sort of treating each of these blocks as a different Lego or puzzle piece, or I guess like pieces of a pipe if you're putting a pipe together. I'm trying to be in frame. So I might do that and do a little bit of experimentation and model comparison, and just look at the output with my eyes. So it's not something where we can do something like, grid search, because it's unsupervised, and I want something that looks good to me. So I like where we talked about measuring success up here. I'm gonna have to do like manual verification just to see if it looks good, and then maybe once it's been implemented, if other people are using it, they can do sort of like an upvote downvote on the output to help me pick models as well. We'll see. Yeah. Okay. So what else would folks talk about? So Matt Ranger says, this is a similar version to taking out the expected value with word embeddings is taking out the first principal component in my experience. Trick comes from Aurora? That's not Aurora because there's no U. Aurora? A simple but tough to beat baseline for sentence embeddings. Interesting. So they do embedding, they do dimensionality reduction using PCA, and then they take out the first principal component, and then this can give you apparently an empirically very helpful way to figure out what words are novel in your specific data set. So basically we're trying to remove stop words and developing a set of stop words based on our particular corpus, because like in general, Kaggle is probably a pretty interesting word. If I were just like reading news sites, I'd be interested to know if someone mentioned Kaggle on a news site. If someone mentions Kaggle on Kaggle, I don't care, man. Everyone mentions Kaggle on Kaggle. So it's like a stop word that I'd want to remove in this context, but not in other contexts. So another thing that they mentioned was embeddings, PCA, remove first principal component is a trick, and that was from this paper. Why can't I highlight things? All right. So other things that people mentioned, and I had quite a few replies, but I do want to sort of go through them and compare them. Deep autoencoder and UMAP. Probably going to be overkill for my specific problem because I am going to have to retrain this model. Leland again says, building an ensemble of PLSA models because they are a cheap version of LDA, using that to find stable topics by clustering the topic vectors and then refitting to the stable topics. This seems to be working okay so far. I have never heard of PLSA. All right, so here's a blog post about it. Probabilistic latent semantic analysis, a technique used to model information under a probabilistic framework. Latent because the topics are treated as latent or hierarchical variables. Latent variable model. So, okay, so instead of, so far this looks the same as traditional LDA, where each topic is a mixture of words and each document is a mixture of topics. Topics are hidden variables. We select a document with probability D. For every word in this document, select a topic from the conditional distribution with a probability, select a word with a probability, and I'm going to talk about it later. So I'm not entirely sure how this is different from LDA because it seems pretty similar to me, but it might be another good thing to check out, see if it works well. And that was PLSA. Oop. I don't know why I'm having such trouble typing today because I'm tired. That's why. Cheaper version of LDA. Okay. UMAP and TSNE of word embeddings is fun to pick out semantic groupings. So this would be good for like data, like the initial analysis. So dimensional reduction, and then TSNE is like a visualization technique. But I don't think it's going to be super helpful for my particular problem. Also, I definitely thought Shannon Quinn was a woman and have learned otherwise. All right, so there's a notebook in the GenSim repo, which uses a topic called coherence, which makes the terms extracted using LDA and LSI seem much more like a human had chose them. So LDA output can sometimes be a little bit crunchy. Ryan says, I don't really think anything embedding based will work well because the embeddings vocabulary won't have anything new. Oh, that is a good point. So I'm just typing, might be a problem if we don't train new embeddings for each time we run the model. Yeah. Yeah, and if we use pre-trained embeddings, they're not going to have embeddings for things like BERT or NACL or rare terms that are important to us. So we're going to have to do our own embeddings if we do this, and that's going to take a minute. Because embeddings tend to be fairly expensive to train and also require a lot of things. And Med says fast text would work. So I'm going to toggle this. Fast text can handle out of vocabulary words. And then Christopher mentioned subwords embeddings, which might help. I don't think they'd work super well with new acronyms, though, because, I mean, acronyms are made up of subwords, but I don't know of any embedding system that handles acronyms really well. Yeah. And I do want this to be a little bit fast to run, so embeddings might be a little bit of a bottleneck. Interesting, but also all of these methods with where you take embeddings and then remove, and then do PCA and then remove the first principal component would work with sort of any matrix-based representation of word co-occurrence. So I'm not super duper worried that these the sort of the pipeline that we try won't work with other things. Ryan says, subword embeddings are a decent band-aid, but like with BERT, you wouldn't expect to figure that out. And yeah, I would definitely need custom embeddings. So I think my big thing is biggest factor, how long do they take to train? All right. Someone says, for shorter documents such as sentences, and a lot of forum posts are one sentence, use embedding plus HDB scan. So I'm not familiar with use embedding. Let's see. How do you use embedding layers? No. MLP. Nope. NLP. There we go. I don't know what use embeddings are, and I don't know what, because this looks like an acronym to me, so let's see if putting it in quotes helps. How to use word embeddings. Use embeddings. Don't use embeddings. All right, well, I have no idea what this type of, oh, it's a verb. But see this, I don't know. It looks like it could be an acronym, but if it is a verb, then we've just successfully searched it. Oh, thank you. Andy says universal sentence encoder. Thank you. I would never have figured that out with the internet. All right. Oh, it's a Google project. Never heard of it. Okay. Tell me about it, I guess. No. Go away. Universal Sentence Encoder encodes text into high-dimensional vectors that can be used for text classification, semantic similarity, clustering, and other natural language text. They've got pre-trained ones, one that works with transformers, and one that works with a deep averaging network, and Dan, also don't know what that is. The two have a trade-off of accuracy and computational resource requirement. Well, the one with transformer encoder has higher accuracy, it is computationally more intensive. The one with DNA encoding is computationally less expensive with lower accuracy. Okay, so that might be another way to do embeddings. Again, we're probably going to have to retrain our own custom embeddings each time. And he says, it's working well for me now, classifying tweets. Helpful. Spectral clustering, which is another thing I'm not super familiar with. Tell me about spectral clusters. A technique with roots in graph theory, where the approach is to identify communities of nodes in a graph based on edges connecting them. Oh, interesting, where the edge must be co-occurrence. Interesting. I've never heard of this. This is a really interesting technique. I mean, I heard about it on Twitter this week. In multivariate statistics, spectral clustering techniques make use of the spectrum eigenvalues of the similarity matrix of the data to perform dimensionality reduction before clustering in fewer dimensions. The similarity matrix is provided as an input and consists of a quantitative assessment of the relative similarity of each point of pairs in a data set. And I'm guessing that quantitative assessment for for words would be something like co-occurrence. Let's see. Given an enumerated set of data points, the similarity matrix may be defined as a symmetric matrix A, where aij greater than 0 represents a measure of the similarity between data points with indices I and j, where I is the columns and j is the rows. No, I is the rows and j is the columns. We talked about that during the reading group. A general approach is to use the standard clustering methods on relevant eigenvectors of a Laplacian matrix of A. Interesting. So you could use this with straight up embeddings. Related to dbScan, they're finding densely connected components. So the big difference here is that we have graph edges instead. So we have edges between nodes instead of just a vector space. Interesting. Was popularized in 2000. So it has a long history, 69, 72, 73. Okay, so it's been around for a while, and then was popularized in 2000 and 2002. Ryan says, looks like it's time to just go down the scikit-learn list because all of these are there. Andy says, use is considerably more advanced than just average word vectors. I can't say I understand it well, though. Okay, so maybe we read that as our next paper. Seems relevant. LDA, they just try a bunch of different stuff. Non-negative matrix factorization, universal sentence encoder embeddings. Oh, if we just kept writing, we would have gotten it. And then UMAP for dimensionality reduction. So for dimensionality reduction, it looks like people are split between UMAP and let me start a new section. I know that my notes are a little bit of a mess, but this is what the first draft of all my papers look like, and then I go through and organize my thoughts. So embeddings, or let's just say for right now we're going to use embeddings, and then actually I want this to be numbers. Embeddings, dimensionality reduction, and then clustering. And then we have sort of things that we can pick from each of these. So UMAP is one, PCA is another. For clustering, we could do dbScan or HDBScan or spectral clustering. For embeddings, we could do, let's just call TF-IDF an embedding. Let's just call it that one. We could do LDA, but that's going to be a pain. We could do, what was it? IPLS? What was the other one? PLSA. PLSA. Or I guess, I don't know, what would you call this step? Words to numbers. We could do embeddings, and for embeddings we could do fast text, which I remember in my brain as only being available in Java, and I could be wrong about that, and I hope I'm wrong about that because I ain't using no Java. Not happening. My first programming course was in Java, and it was not a fun time for me, and I'm sure that I'm just like conflating the things I didn't like about the course and the things I didn't like about the programming language, but I still got a grudge. Embeddings, use embeddings. We could do, I guess we could use glove if we wanted to. Oh yeah, word to vec. Jer says, why has nobody suggested tsne for dimensionality reduction yet? It looks like nobody is using it in that place in their pipeline. They're usually using it more for TKM. I don't know what that is. They're usually using it more for visualization. Text to knowledge mapping. Oh, that sounds extremely promising. And also, I still can't highlight text good. Mapping text to knowledge graph entities using multisense LSTMs. Oh, okay. So the big problem here is that we probably need an existing knowledge graph, and I do not have bandwidth to build the Kaggle specific knowledge graph. So that might be something that would work in a different application, but not for me right now. Depict deep clustering using EM. The Interlife says, what about Elmo embeddings? Oh yeah, good call. Elmo. Although, so I don't know as context is going to be super helpful here. I think we might be, I don't know about use embeddings, but I think we might be good with bag of words. I could be wrong on that, but that's just sort of my gut instinct. Blah, 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 blah. Deep clustering via joint convolutional autoencoder embedding and relative entropy maximization. There's no way we have enough data for this. No one mentioned top SBM, excuse me, topic models based on stochastic block models. Okay, I am definitely intrigued by this that says that it's better at finding these topics than LDA, so that might be useful. It looks like it's a hierarchical model. It uses Python, hopefully. Let's take a look. And then they've got a Jupyter notebook tutorial. I'm extremely into this. Nope, that was a link to jupyter.org. Okay. Oh, okay, I see it's in the repo somewhere. Interesting. Yeah. Hierarchical stochastic block models. Not familiar with this, but this could be super useful for us. So let's put this under clustering, I guess. Let's check out the notebook real quick. Oh, it is 10:04. I got stuff to do. The Answer Life says, the distance between each point in tsne does not resemble the distance in high dimensional space. Necroduke says, is a knowledge graph similar to a taxonomy? I'm not super familiar with the taxonomy, so maybe. And Yulong says, graph neural network. Graph neural network. We're probably not going to use a neural method for this particular problem just because of the constraints that I'm working under, and also I don't want to spend a bunch of time tuning. Ugh. I don't really like working with neural networks. That's my, even though we mostly read about them in the reading group, that's my confession. I don't love them. They're just so fiddly, man. It's like pastry. Like, you could make pastry, or you could just make cookies and be done in half the time and still have a delightful baked good. If we're going to have to make a graph, though, this may be very time intensive. Interesting. Okay, so this is a topic-based model. Topic distribution in each document. Clustering of documents for free. Okay, so this looks like a whole pipeline. Yeah, heck yeah, we can definitely try this out. This looks like a really interesting potential project that could work really well for us, or could be a huge mess. So we'll find out. I do want to get to the bottom of this thread. We're almost there. So we do sentence to vec and sentence similarity, like the USE, using IDF word to vec. Okay, spectral clustering. So some votes for spectral clustering, some votes for DB scan. Jer has a thing that they mentioned. About mining topics, and I'm gonna go through and read this in my own time. So thanks for tweeting. No, that's not the one I wanted. I wanted mine. There we go. And I want to say I am grateful every day for the fantastic Kaggle community and people answering my questions and sharing knowledge, and it's really nice. Some votes for Bayesian. No fiddling, just pure mathematical inference. I actually do tend to prefer Bayesian methods. Neural nets aren't so bad. They're not. They're just fiddly. Bayesianization of Bayesian models with Bayes. All right. Vlad recommends big RTM, which I'm not familiar with. I think this is just a comment on my choice of emoji. Why can't I highlight text? I'm gonna need to mess with my mouse sensitivity settings. So that's something we might should look into. And then somebody just sending this to somebody else. So big RTM might also be another option. And I can see what languages it's in. C++. I would prefer not to. But maybe it's a Python wrapper on C++, so that would be not so bad. Multi-objective models. Known to combine different objectives. It's kind of cool. All right, so this is something else that could potentially be helpful. Do you guys have a notebook? Because if you don't have a notebook, don't even talk to me. No, that's not fair. Plain text files, it uses HTML, blah, 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 blah. Okay, so this might be another thing to look into. I think what we can start talking about next week is putting together this sort of experimental pipeline to try different things and see what works. And I don't know ahead of time what's going to work, because that's the joy of machine learning. Yeah, so thank you for joining. I went a little bit over as the coffee has kicked in. I think I've picked up steam. And thanks to everybody who replied to the Twitter thread. Super duper helpful. I've definitely expanded my own personal knowledge of what's going on in the unsupervised learning for text space, and hopefully this was helpful for you guys as well, and you learned something new. Even though there wasn't a lot of coding, there was a lot of learning about algorithms. Yeah, thanks for joining, and I will see you guys on Wednesday. We're continuing. We got over the hump of the paper that we're working on right now that I can't even remember what it's about. I'm just getting flashbacks to trying to get through the model specification part of the paper, and it was rough for me. Sparse transformers for sequence generation. There we go. So we've looked at why they're sparse, and now we're going to look at how they do. Spoiler alert, probably state of the art, because otherwise they wouldn't have published it as a paper. Well, it's not published. Shared it as a paper. And then on Monday, I've got a Kaggle coffee chat going up. So we talk a lot about sort of like pipelines and infrastructure and putting data science in production and that sort of thing. So if you're working, that might be an interesting one for you. Yeah, have a great weekend. If you're in Seattle, I'm going to be giving a talk tonight at the Ministry of Silly Talks over in Kirkland. So I think there's still time and space to RSVP if you're interested. And I'll post the slides from that as well. I'm going to be talking about language models. Hey! All right. Thanks so much for joining, guys. And I will see you on the internet. Bye!